So yesterday we talked about how the sine, cosine, and tan, their value is different if you have an acute angle or an obtuse angle. And we learned that if it's an acute angle, sine, cosine, and tan are positive, and angle, cosine, and tan are negative. Okay? Today we're going to explore why, and then we're going to try to find angles if we are given certain ratio. Okay? So let's just recall an acute angle is less than 90 and obtuse is between 90 and 180. And then supplementary angles are two angles that add up to 180. Good. So this all comes to the Cartesian plane. So we're going back to the x and y plane, okay? Because, so what you guys remember, so this is your Cartesian plane, right? So this is your x, this is your y, and you have 4 quadrants, right? You have quadrant 1, quadrant 2, quadrant 3, quadrant 4, all right? Quadrant 1, both the x and the y are positive. Quadrant 2, which one is negative? X is negative, y is positive. Quadrant 3, both negative. Quadrant 4, good. In this course, we will only deal with the quadrant 1 and 2, so we will not talk about quadrant 3 and 4, okay? Because we're only dealing with angles between 0 and 180, okay? Now, let's look at an example here. So instead of using opposite over hypotenuse or adjacent over hypotenuse, we're going to use now the x and the y, which is the coordinate of a point. So let's say I have a point xy in quadrant 1. So let's just look at an example here, and let's say this is my xy plane. Right? And if I have a point at 3, 4, and this is my point. Okay? Now, I have point 3, 4. How can I draw a triangle with this point? So a point from where though? From 0, 0. From the origin. That's right. So you're going to draw the triangle from the origin. Okay? So we're going to come from the origin. It's going to come all the way to the point. That's going to be your hypotenuse. Okay?
Go back to the 3.
Yeah. Go back down. So the triangle is always going to have to be formed with the x-axis. Okay? So you always have to drop it down to the x-axis. Okay? So this is your right angle right here. And your angle of interest is the one from the x-axis to what we call the terminal arm. So this right here is called terminal arm. Okay, so this is the arm of the triangle that join the origin to the point of interest. And then the angle of interest is the angle formed between the x-axis and the terminal arm. So this is your angle of interest. Terminal arm, yeah. Sounds like we're going to the airport. So you see your triangle? Okay. Now, what are the lengths of your sides?
Sorry?
3 and 4, the length of your sides. Yeah. So 3 is this, and 4 is the height. So this is going to be 3, and this is going to be 4. If I'm looking at the triangle according to the angle of interest, this is my opposite, right? But it also, I call it y, right? In this case, because that's the y value of the x point, of the point, sorry. Right? So if I'm just going to draw the triangle here. So this is my angle of interest. This is 3. This is 4. We used to call this the opposite, but it's technically now it represents the y value, right? Because it's the y value of your point. And then we used to call this the adjacent, but now it represents the x value. Okay? So instead of using opposite and adjacent, I'm going to be using x and y. Okay? Now, and that we used to call this the hypotenuse. Now we're going to call it r. That represents the radius of the circle if I actually form a circle. So if I actually take this, put my compass right here in the middle, and draw a circle that passes through this point, this is going to be the radius of the circle. Okay? So we call it the letter r for radius. Yes. Okay, so it's just we're changing the naming. We're not changing anything else. Instead of opposite, we're calling it y, because that represents the y value of your point. Instead of the adjacent, we're calling it x. Adjacent is x. And instead of the hypotenuse, we're calling it r. Why? Because I said so. This is why I tell my kids. It's okay. Why? And this is going to be theta, right? This is the angle of interest theta. So let's look at this. If I'm looking at sine theta, what's the formula for sine?
It's going to be opposite of the hypotenuse.
Which is what?
It's going to be y over r.
Okay? Cosine theta. Yep. This will have. And then tan theta. Y over x. Good. So now we're going to use the numbers that I've given you, which is the 3 and the 4. First of all, to find r, because we don't know what r is, and to find the tan, cosine, and whatever. Okay? So let's do this. How do you find r if you know these two sides? Because we are looking at Pythagorean theorem, right? So it's a squared plus b squared, or x squared plus y squared. So that's going to be r squared equals 9, because 3 squared 16, which is 25. So r equals 5. So, yeah. So if I'm going to actually evaluate this, sine theta is going to be 4 over 5. Cos theta is 3 over 5. And tan theta is 4 over 3. Are we okay with this? So the most important part here is to be able to draw the triangle properly. Okay? Make sure that when you're drawing the triangle, first of all, you're locating your point. You're drawing the terminal arm between the origin and the point, and then dropping the vertical line coming down to the x-axis. Yes?
The longest part starts from 0, this intersection of 0 and x and y.
Yep.
Right there?
Always.
So always.
Always. Yep. Okay? And you need to remember these formulas. Okay? You need to remember that now. Sine theta, we're going to say it's y over r. Cos is x over r. If you don't remember it, draw the triangle on the Cartesian plane and then recall the SOHCAHTOA. Okay? Remember, I'm using SOHCAHTOA here because it's a right angle triangle, right? And Pythagorean theorem. So I'm using both Pythagorean theorem and SOHCAHTOA. Okay. Now, how would this be different if my point is in the second quadrant?
It's gonna be negative.
What's going to be negative?
The x.
The x is going to be negative. Okay, so let's look at that. Are we done with this? So, we're going to take the point at negative 3, 4. I just want you guys to remember something, that always the angle that we measure, if I'm going to measure an angle, I'm going to measure it from the x-axis. Okay? So if I'm going to measure my angle, I'm going to measure it from here to here. Okay? That's how I would measure my angle. But then because I can't draw a triangle in this section, I'm going to draw a triangle here. Okay? Now, I want you to look at me for a second and tell me something, what we learned yesterday. Yesterday we learned something about supplementary angles. And we learned that if they're supplementary angles, so if they add up to 180, their sine, cosine, and tan, they have the same value, but one is going to be positive, the other one is going to be negative for cosine and tan. Do you remember that? So we talked about, like, if it was, don't write this, if it was like cosine 120, right? It's going to be it's the same as cosine 60, but it's going to be negative that, right? But it's going to be the same value. Right? So we're going to have to look at this and we're going to have to understand that it's going to be the same value, but one is going to be positive, the other is going to be negative. Okay. Now, which means this angle or this angle right here, they're going to have the same ratio, but I have to remember that the original one's going to be negative, right? My original angle, which is an obtuse angle, right? Because this is obtuse. Do you guys agree that this is obtuse? Right? Do we agree that this one here, which I'm going to call, not x. I'm going to call alpha. Do you guys agree that alpha is obtuse? Right? Because this is technically angle 0. This is angle 90, right? This is angle 180, right? So this is going to be bigger than 90. We agree on that. Okay. Now, this is my angle alpha. Theta. So let's name that triangle. What's this? That's y.
Axis of symmetry.
And it's equal to 4. What's the bottom here? X, and it's equal to negative 3. And then what is my radius? So r squared equals to negative 3 squared plus 4 squared. So that's going to be 9 plus 16, which is 25. So r equals 5. Okay. Yeah. That's right. That's right. Exactly. Now, if I'm looking at angle theta here, sine is opposite over hypotenuse, right? So, or y over r. And then what's y?
4
Good.
over 5.
How about cos?
X over R, -3/5.
Negative 3 over 5. Cos turn out to be
Negative.
negative. Why?
Because
Because I have my original angle as an obtuse angle. Huh? Now you know why it's negative? Good. How about tan? Y over x. And what's y? What's x? Is that negative 2? Yeah. So it's not coincidence that obtuse angles have negative cos and tan. And the reason for that is because they lie in the second quadrant. And in the second quadrant, the x is negative. Okay? Now, here's some vocabulary that you guys have to know. Okay, just have your attention here. So, this angle right here, we call this angle the obtuse angle, right? Now, angle theta, which is this one, we're going to name it the supplementary acute angle. It's supplementary to which one?
to the obtuse.
It's supplementary to the obtuse. So my original angle is the obtuse angle. But then I'm using the supplementary acute angle to form my triangle. Okay? So in this case, sometimes you're going to have an acute angle with a supplementary obtuse angle. So it depends on where your location is. So are we good with that? So here's what I want you guys to do. Use your calculator to solve for angle theta for me. Yeah. So here's a question. I want you to try it with all three of them. Let's see what you guys get. Try, so do sine inverse, because you're looking for angle theta, right? You're going to do sine inverse of 4 over 5. Tell me what you're going to get for this. Because you need to be aware of what the calculator is giving you. 53. 53, that represents which angle? The acute. That represents the supplementary acute angle. But if I'm asking you for the obtuse angle, what answer should you give me?
180 minus.
That's right. So the answer that you're going to get for this is 53, and that represents the supplementary acute angle. Okay? But what would be your obtuse angle? You're going to have to give me your obtuse angle, right? So obtuse is, and this is why you have to be aware. So the obtuse angle is 180 minus 53, which is 127. Okay? Now, what if you used cosine and you did cos inverse of negative 3 over 5? Tell me what the answer is going to be. Do cos inverse. 127. So if you do the cos inverse, eyes on me. So if you use the cos and you did cos inverse of negative 3 over 5, it's giving you 127. So the calculator is giving you which answer? The obtuse angle. So that's why I'm saying you have to be aware of what the calculator is giving you. Now, do tan inverse for me. What is it giving you? It should give you negative 53, no? Try again. Negative 53. And this is where you're going to even have to use your brain a little bit more. So, here's the thing. I'm going to open a new page here. So when I'm measuring my Cartesian plane, when I'm measuring angles in the Cartesian plane, I don't want you to write this, I want you just to pay attention to me. Okay? So when I measure my angles in the Cartesian plane, I always measure from the x-axis and I go counterclockwise. Okay? So that means if my angle is here, right, then I measure from the x-axis counterclockwise. And I say, let's say this is 3 degrees, right? Or if my terminal arm is here, I measure from the x-axis to the terminal arm, and I say this is 127 degrees. I'm just giving you examples, okay? Or if it's here, again, I measure from here to here, and that would be 210 degrees, okay? So I'm always measuring from the positive x-axis counterclockwise, okay? Now, if I have this, right? Sometimes the calculator is going to give you a negative answer, right? Which it just did, a negative angle. And that negative 53 means the following. Instead of, eyes on me, instead of going counterclockwise, it's actually measuring from the x-axis clockwise. So negative 53 is here. It's not wrong because we don't learn these two. And technically this answer is correct, but I have to make it into positive. So here's what I want you to do for the purpose of this course. Once you get a negative 53 degree or negative answer, you're going to pretend that you don't see that negative. And you're going to pretend that it's a measure of the related supplementary acute angle.
So that would be
It's going to be only with tangent. It's only going to be the tangent that's going to give you a negative answer.
So when we solve, we erase the negative sign?
Yes, but remember, it will be the supplementary acute angle. Okay? And it's only tangent that's going to give you a negative answer when you do the tangent inverse. Okay? But the reason for that, it's giving you a negative, is because tangent is also negative in the fourth quadrant. So tangent is not only negative in the second quadrant, it's also negative in the fourth quadrant. And the calculator is programmed to give the answer in this quadrant.
so all the calculators are like that?
All the calculators are programmed to give the answer in this quadrant. I don't know about the phone calculators though. Okay? So, remember that if you do tan inverse and you get a negative answer, you're going to omit that negative, and then you're going to remember that this is the supplementary acute angle measurement. Okay? If you can avoid using tan, avoid using it. If you can't, because the question is telling you that tan theta equals negative 0.0321, find the answer for theta, then there's no way that you can avoid this. Okay? And then remember that sine is always going to give you the first quadrant answer. Because sine is positive in which quadrant?
Sorry?
Sine is positive in which quadrant? Just in a second, both of them, ones that we're learning about. Okay? And that's why when you do sine inverse, it's going to give you the acute one. Right? Because sine is positive in the acute one, and the calculator is programmed to give you the sine positive in the first quadrant. Okay? It all depends on the programming of the calculator.
Is this what I'm going to test on Tuesday?
Yeah. Everything we learn. Yeah.
You asked something. I wasn't sure of your term, that of something. When you were asking me this, the ratio.
Yeah.
What did you ask?
I find the angle.
No, you said something. Theta, yeah, theta. You said something else.
Alpha.
When you were referring to
When I'm referring to this.
yeah.
Yeah. Primary trig ratios. I don't know. I can't remember. Okay. Sorry. Can't remember. What? Mm-hmm.
We are going to find it by sine. But since sine gives us both positive values, right?
Mm-hmm.
How would we know if there is no quadrant there?
You're going to have to find me both answers. And that's a question. A good one. If I say sine theta equals to, and I give you that, and I don't tell you which quadrant it's in, and I say sine theta is, and that's a question on the test, by the way, is 0.45. I give you that. And I say find me angle theta. Do you know if it's in quadrant 1 or quadrant 2? But it could be either way, right? It could be either answer. So you must find me both. So you're going to do sine inverse of 0.45. What do you get?
0.45.
Sine inverse.
27 degrees.
27 degrees. That's one answer, and you get 1 mark for that. The second mark is going to be finding me the supplementary obtuse angle, which is 180 minus 27. So these are the two answers that I'll be looking for.
I was asking then.
Yes. That's what I was asking for. What is it? Oh, the theta. 153 is in quadrant 2. So your angle could be either here at 27, or it could be here at 153. Okay? You can have either or. Okay, this is a question that does not belong to this question, boy. All right. This question is asking you for, suppose angle C is 123 degrees. Using your calculator, determine the trig ratios for angle C, rounded to 4 decimal place. So what do? What's the trig ratios again? So sine 123, because I gave you the angle. So what's sine 123? Or would be cosine 123?
The primary trig ratio, so sine of 123, cosine 123, tan 123. Simple, easy.
What? Nothing. That's what the question's asking you for. You stop. Stop thinking ahead when the question just simply asks you. Because I'm going to start taking marks off for extra stuff. All right. So here's the thing. If sine A is an acute angle, right? So the obtuse angle would be what? The supplementary obtuse angle would be what? 180 minus A, right? And then the sine of that angle is going to be exactly the same, right? So that means the sine of A and the sine of its supplementary obtuse angle is going to be equal, right? They're going to be equal to each other. So for example, if I have sine of 60, it's going to equal to sine of 120. Yes? You guys agree with me on this? Are we okay with this? Right? Because 60 and 120 are supplementary angles. They add up to 180. Good. How about cosine of 60 and cosine of 120? So cosine 60 is going to equal to negative cosine 120, yeah? So if I'm going to write this as a formula, right? I'm going to write it as
G5. And how can I make these two equal to each other? This is 0.5, this is negative 0.5. If I multiply it by a negative. And that's what I just did here. I multiplied it by a negative. So they're equal to each other, but they're negative each other. They're the opposite sign of each other. You won't be using this one a lot, just so you can. What's tan 60 compared to tan 120? Okay, so I write it as negative tan 180. So you're going to have to be able to relate between the acute angles and their supplementary angles, or with the obtuse angles and their supplementary acute angles. Okay? So let's look at the last question. So this question is asking you to write the measure of each. Look at the question and listen to it. Write the measure of each supplementary obtuse angle. So what angle do they want? The obtuse. So if your answer ends up being acute, you're going to have to find the obtuse. So the sine of acute angle P is 0.6. So sine P is 0.65. How will you find angle P?
Inverse.
So do the inverse sine. What do you get? 41 degrees? Okay. So is that the answer that I'm going to leave it to? No. I have to find the supplementary obtuse angle. To find the supplementary obtuse angle, what do I do? 139. Supplementary obtuse angle. Okay, so S This doesn't want to work. OA. And it's acute, it's SAA, because I'm too lazy to write it all. So the cosine of the acute angle R is 0.22. So that's telling that cos R is 0.22. What do I need to find? First, I have to find angle R. And how do I do that? Cos inverse. $77. And then what would be my supplementary obtuse angle? What is that, 103?
Oh, yeah.
Okay, can you guys do the last one by yourself? All right. I just have to make sure that this stays.